Today's topic will cover timers and counters. The FANUC ladder logic has multiple types of timers and counters that can be used in it. This is a description of some of these function statements. You will see how they are configured, used in a ladder program to cause alarms, and then reverse engineer the alarms to fix the problem. At the end of this lab, you will be able to identify the various types of timers and counters used in the ladder and get a thorough understanding on how they are used. There are basically two types of timers and counters used on the FANUC controls. These are variable and fixed. Variable means that you can easily adjust the values. This is done by going to the timer or counter screens and inputting a new value. Fixed means that the timer or counter value is hard-coded into the ladder. In order to adjust these, you will need to edit the ladder. Let's start with timers. Timers are a function statement in a PMC. Like all function statements, each type of timer is given a unique subnumber. The ones we will cover today will include sub-3, your variable timers, sub-24, fixed on delay timers, sub-77, fixed off delay timers, and sub-54, which are also variable timers. The availability of these timers will depend upon the model control that you are using and the type of FANUC ladder logic that is in it. Each of these timer function statements uses a contact known as an action command or ACT to start the operation. Basically, this gets the timer to start timing. The actual time value can deviate depending upon the scan time of the ladder. Timers in level 1 of a ladder will be more accurate. Level 2 timers may deviate due to the scan sequence. Like many function statements, there are settings that determine how it will be used. Let's start with the sub-3 timer and see how it works. In the ladder logic, you will find a sub-3 timer drawn as shown. Now, a sub-3 timer, also known as a TMR timer, is a variable timer. You can set a value for the timer in the timer settings page found in the PMC maintenance screens. In this case, the time is set to 5 seconds. Note that the value is in milliseconds. Please pay close attention to the timer number. This is where you will locate the settings for this timer. Do not confuse it with the timer address. Doing so will have you setting the wrong value. This will screw up the machine. You will see that certain timers have a preset accuracy level. For instance, timer number 2 has a preset accuracy of 48 milliseconds. If I try to enter a value between 1 and 47, it will not accept it. The minimum value that I can put in is 48. FANUC controls will round this value off to the nearest accuracy it can accept. For instance, my data sheet says I'm supposed to enter a value of 100 milliseconds into a timer. But when I enter the value, it changes to 96 milliseconds. The reason is that this timer has an accuracy of 48 milliseconds. It will round the number down to the nearest value it can work with. Don't worry about this. That's the way it's supposed to work. Timers 1 through 8 are set to 48 milliseconds. Timers above this are set to 8 millisecond increments. On new style controls, you are now able to change the accuracy level of the timers. This is done with the accuracy soft key. I don't recommend doing this on any preset timers. Once again, this will screw up your machine. So I've got the time value for timer number 10 set to 5 seconds. Yeah, it's in milliseconds. Each timer is given a unique number that identifies it. These numbers should not be duplicated. Unfortunately, there is no way to search for this number in the ladder. If you have a hard copy of the ladder cross-reference, it will be listed showing the network number. You can search the network number to locate the timer in the ladder. Now, the output coil shown here will turn on when the timer has reached the value set in the previous screen. It will stay on as long as the action command remains active. If this contact goes low for even one scan of the ladder, the timer output will turn off and the process will start all over again. Variable timers can be used for items such as lube pump on and off time, indexer rotation overtime, door open, close overtime, or other functions. The sub-24 function is known as a TMRB timer. This is a fixed timer. This means that you can't modify the timer value. This timer behaves just like the TMR variable timer. This timer does not have an accuracy level and can be set up to around 546 minutes. When the ACT signal command goes high, the timer will begin to time out. Once it's timed out, it will turn on the output. This output will stay on as long as the action command signal is high. If ACT goes low for even one scan of the ladder, the output will turn off and the process starts over again. A good example for the use of a fixed timer will be something such as the amount of time it takes the tool changer to complete its operation. Typically, you shouldn't need to alter the value from the one set by the machine tool builder. Like the variable timers, each TMRB timer is given a unique number. These should not be duplicated in the ladder. The next timer I'm going to talk about is the Sub 77 fixed off delay timer. Now this is called a TMRBF timer. It works a little bit different than the other timers. In this case, the output turns on as soon as the action command goes high. When the ACT command goes low, the output will stay on for the time shown here. Basically, this is an off delay timer. This is fairly new to the FANUC. Up until this time, all timers were on delay. TMRBF and TMRB timers share the same timer numbering system. Be sure to use a unique number for each. The time values can be set up to 546 minutes. Now the Sub 54 timer is a little bit fancier. This is a TMRC timer. Let's see how this one works. Like the variable timer, Sub 3, this timer allows you to adjust the time before the output turns on. The difference is that the time value is stored to an address instead of the timer table. Typically, this is done with a data address in the data tables. Like the Sub 3 timer, this timer also has an accuracy or increment level. This is set in the first line. The setting shown here will set the increment level for this timer. Generally, a setting of 0 is used to establish this as an 8 millisecond timer. Other settings can be used. The address that holds the time value is input on line 2. This is typically a data address. Note that this field will take 2 bytes of data. This means that if you set the starting address at D100, it will take addresses D100 and D101 to hold the timer value. This Sub 54 statement is set up for an 8 millisecond accuracy. A setting of 3000 into D100 will produce a time value of 24 seconds. 8 times 3000 milliseconds equals 24 seconds. If I change the accuracy setting to a 3, this will give me an increment of 10 seconds. By setting D100 to a 2, I will end up with a 20-second timer. Timer ranges can be set from 8 milliseconds up to approximately 546 hours. That's a lot of time. Line 3 is the starting address where the actual counting will occur. This address will take up to 4 consecutive bytes of data. So a setting of R700 will use the addresses R700 through R703. These addresses must not be used in a ladder for any other purpose. Please note that, unlike the other timers we discussed, there are no timer numbers associated with the Sub 54. This ends my description of the basic timers used on a FANUC control. Additional timers will be discussed in the future when we cover the extended PMC ladder instruction function.